Okay, everyone, today we're going to start lesson 7, and it is dealing with magnitude. So this is the second half of the module, and we are going to use it to talk about exponential notation a little more and for a specific purpose. In this case, we are leading into scientific notation. And in scientific notation, you might have heard it in science class or in other classes, but remember, scientific notation is just a way to express very large or very small numbers. So today we're specifically going to focus on magnitude, and I'd be writing this down in your notebook. Or sometimes you might hear a reference to order of magnitude, and this is all dealing with powers of 10, which we're going to talk about in a moment. So powers of 10. And when we think about magnitude, you want to think about how big or how small something is or a value is. And it's a great way to compare numbers. Get in with the actual lesson. Let's think about our different powers of 10. Well, I'm going to start off with 10 to the 0 power. And if I move to the right, remember I am just increasing. 10 to the first, 10 to the second, 10 to the third, and so forth. If I move to the left, you know I am decreasing. 10 to the negative first, 10 to the negative second, 10 to the negative third, and so forth. So if I try to write these values down, and you might want to do this as well, 10 to the 0 power, well, we just learned that anything to the 0 power would give you 1. 10 to the first is 10. 10 to the second, 10 times 10 is 100. 10 to the third, 10 times 10 times 10 is 1,000. And then if we also work backwards, 10 to the negative first, well, you could think of this as 1 over 10, which is also 0.1 because it's in the tenths place. 10 to the negative second would also be 1 over 10 squared, because remember, if I'm dealing with a negative exponent, if I change its location, it becomes positive. Well, 1 over 10 squared is the same as 1 over 100, and as a decimal, it would be 0.01. 10 to the negative third, if I don't want to deal with negative exponents, remember I change its location. So I would have 1 over 10 to the third, which would technically be 1 over 1,000, because 10 times 10 is 1,000. And as a decimal, we would have 0.001, because that 1 is in the thousands place. So like I said, I just wanted to refresh your memory a little bit on powers of 10. Like I said, when you move to the right, your numbers are getting larger by a power of 10. We're just multiplying by a power of 10 every single time. And if we go the other way, if we go to the left, we're really like dividing by a power of 10. So like I said, if we talk about magnitude specifically, this is just talking about how big or how small a value is. And we use this a lot in science, and magnitude always deals with powers of 10. So your base always has to be 10 to a certain power. We don't know what that exponent would be. So down here it shows a little bit of facts that you're going to want to know, and this is what we're going to focus on today. The number 10n, 10 to the nth power. This is going to deal with large values. Anytime I deal with 10 to the negative n, this is going to go with very small numbers. So 10 to the negative n, you're going to have small numbers, so numbers less than 1. 10 to the positive n, you are going to be dealing with very large numbers, which would be greater than 1. But remember, we're always to the 10th 10 to a certain power. Magnitude is always dealing with a power of 10. So before we get into the first example, as always, or exercise as always, I'm going to give you a few examples. So here's going to be the first example I want you to write down in your notebook. It says, let m equal this very large number right here. Find the smallest power of 10 that will exceed m. So basically, I want to find a power of 10. So I want to think 10 to what power would exceed this value. In order to do this, it's quite simple. You're literally just going to count your number of digits that m has. So if I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since I have 10 digits, my exponent would be 10. So the smallest power of 10 that will exceed my original value right here would be 10 to the 10th power. So if you want to write this out correctly, that's what we would have. My original value would be less than 10 to the 10th power. Remember, all I did was count my number of digits. If you would have went 10 to the 9th, you would have been too small. If you would have went 10 to the 11th, you would have been too big. Remember, just count your digits. Here's another example. I want to find the smallest power of 10 that will exceed my original value, which is right here. So just like before, I start with a power of 10 and I need to figure out what my exponent will be. Remember, you're literally just counting your number of digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 10 to the 14th power would be my answer. It's the smallest power of 10 that would exceed or be larger than my original value. So right now I want you to try exercise 1 and exercise 2. Exercise 1 is exactly what we've been doing. You want to think 10 to what power would exceed my original value. And for exercise 2, same thing, 10 to what power would exceed my original value. Now for exercise 2, do not get thrown off with this fraction. 899 over 987 is super close to 1. So I'm going to estimate this number right off the bat to be 78,492. So now I want you to try to find 10 to what power would exceed exercise 1 and 10 to what power would exceed this value we have right here for exercise 2. Pause the video and remember, when you're ready to check your answer, press play. So your answer for exercise 1 would be 10 to the 15th power, because if you counted, you would have 15 digits. Exercise 2, 10 to the 5th power, because you have 5 digits here. So for exercise 3, it says let m be a positive integer. Explain how to find the smallest power of 10 that exceeds it. This is just what I have been saying. All you have to do is count your number of digits, and that will be your exponent. So basically, like I've been trying to tell you, your exponent for your power of 10 equals your number of digits. So one last example, if I gave you 5,678.9, you could literally forget about your decimal. How many digits do I have? Well, I have 1, 2, 3, 4 digits. So I would have 10 to the 4th power would exceed my original value. Remember, your number of digits that you have, excluding any decimals, is your exponent for your power of 10. So here's another example I want you to write down in your notebook. The average ant weighs 0.0003 grams, or you could think of this as 3 10,000ths. I want to express this number as a power of 10. So the first thing I would do is think, well, 10 to the 0 power is 1. This number here is less than 1, so we have to go not positive now, we are going to deal with negative values. So let's first think about what this value is if I read it. If I read that value instead of 0.0003, I could think of it as 3 10 thousandths because that 3 is in the 10 thousandths place. Remember, it goes tenths, hundredths, thousandths, 10 thousandths. So that's the first thing I would do. Next thing I would do is rewrite 3 over what power of 10 would this be? So this would be 10 to the 4th power because 10 times 10 times 10 times 10 would give you 10,000. Now, if we think about our rules for the laws of exponents that we just talked to you about, this would be the same. I could set this up as 3 times 1 over 10 to the 4th power. Well, I know before on the last test we said we didn't want you to have negative exponents. However, there are going to be cases that we will have that, and this will be one of them, especially when we deal with scientific notation or powers of 10. So, basically, I don't want to keep this fraction. I want to rewrite it. So I could change the location of 10 to the 4th. Now 10 to the 4th, I could rewrite it so it goes to my numerator. So then I would have 3 times 10 to the negative 4th. Remember, when you change the location from the denominator to the numerator, my exponent would just switch the sign. So since it's positive now, I would make it negative. And this actually is your answer. 3 times 10 to the negative 4th is the same as that. We are going to work on scientific notation on Friday in particular, but we just wanted to get started showing it to you now. Here's another example I want you to try, and make sure you write this in your notebook, point 004. So I want to start to think about this and write this as power of 10, and technically it would be in scientific notation. Like I said, don't get so hung up on scientific notation right now. We will be working with this later on. But, so if I wanted to rewrite this, remember, this is in the tenths, hundredths, thousandths place. So that would be the same as 4 over 1,000. If I wanted to rewrite that as a power of 10, I would have 4 over 10 to the 3rd power, because 10 times 10 times 10 is 1,000. Remember, then I'm just going to separate this, so I have 4 times 1 over 10 to the 3rd power. But remember, I never want to have this fraction, so I'm just going to change the location. And when I change the location to my numerator, my sign would just change. So my final answer would be 4 times 10 to the negative 3rd. Let's try this example now. If I would give you 0.02. Well, I know this is in the tenths, hundredths place, so this would be the same as 2 100ths. If I rewrote that as a power of 10, I would have 2 over 10 squared. Remember, I usually separate this just to have the power of 10 by itself. You never want the fraction to be in your final answer. So remember, when we change the location, you just change the sign of your exponent. So this would become 2 times 10 to the negative 2nd power. If we look at exercise 4, I'm going to start us off. I'm going to rewrite that value as a power of 10, so I would have 1 over 10 to the 13th power. And remember, I never want it as a fraction, so I'm just going to rewrite it. When I change the location, just like the rules we've been discussing, my sign changes. So since it was positive, now it becomes negative. In exercise 5, it says the chance of winning a big lottery prize is about 10 to the negative 8th, and the chance of being struck by lightning in the U.S. in any given year is about 0.000001. Which do you have a greater chance of experiencing? Explain. Well, when they want you to compare numbers, think about the magnitude. Well, the lotto has a magnitude of 10 to the negative 8th power. The lightning, if I would write this, remember I had 0.000001. If I would rewrite that as a fraction with a power of 10, because it's less than 1, that's why we're in fraction form, I would have 1 over 10 to the 6th power. But remember, I want to be able to compare this number that's not in a fraction to this number that is, so I just have to change its location. So this would become 10 to the negative 6th power. What says, which do you have a greater chance of experiencing? Winning the lottery or being struck by lightning. And in this case, be careful, because actually you'd have a greater chance of being struck by lightning, because 10 to the negative 6 is closer to 0. It's moving to the right more, because remember, since you're dealing with negative numbers, the farther you get away from 0, the less likely. The closer you are to 0, more likely. Okay, so just to wrap everything up, no matter how big a number is, we can always find a power of 10 that is bigger. Also, very large numbers are always the positive powers of 10. They always have positive powers of 10. Very small numbers are negative powers of 10. So even though the small numbers are greater than 0, they're positive numbers, they still have negative powers of 10. And we're going to talk all about this in the future. I just wanted to give you a heads up. So your homework assignment for tonight is to do the 5 problems that you see, which is in the next page of your packet. In addition, your teacher will be handing you out one more practice sheet. So I hope you understand magnitude a little bit more, which deals with powers of 10. Very large numbers have positive powers of 10 as the exponent. Very small numbers have negative powers of 10 with the negative exponent. And as always, ask your teacher for help. Enjoy the day.